fine. For now, you need to use the cheat sheet. The more these would do, you're going to memorize what the points are and what the values look like. Don't forget the arrows because they go up to infinity and negative infinity. So step number 1 is draw the base graph. Step number 2, we want to describe the transformations. I'm going to start with the -2. Inside brackets or outside brackets? Inside brackets means it is a horizontal translation. 2 units to the right. Remember, it's opposite of what it looks when it's horizontal. The -1 is it inside brackets or outside brackets? Outside means it is a vertical translation, 1 unit down. So step number 2 is describe the transformations. Step number 3, we're going to draw them. Grab your red pen because this will be our last graph. All I'm going to do is point by point, I'm going to take and count 2 units to the right and 1 unit down. So I'm going to start at -2, -8. 2 to the right, 1 down. Then I'm going to -1, -1. 2 to the right, 1 down. Then I'm going to the origin. 2 to the right, 1 down. 1, 1, 2 to the right, 1 down. 2, 8, 2 to the right, 1 down. And then join them. The last step is going to seem a little silly when we only have 1 graph, but again, what's coming in the unit is we're going to have 3, 4, 5 transformations at the same time. Is I want you to go look back at where you described the transformations, and I want you to double check. Did I do on the graph what I said I was going to do? So did I go 2 to the right and 1 down? So look from the black to the red. Can you see that it moved over 2 and 1 down? Because sometimes what happens is you say one thing here and you end up doing something different over here. So the last step, I like to just double check from the description, did we do what we said we were going to do? If you're a wordy person, I will repeat the steps. Step 1 is draw the base graph. Step 1, draw the base graph. Step 2, describe the transformations. Describe the transformations. Step 3, draw the transformations. Draw the transformations. And step 4, double check the description. Double check the description. So make sure the description matches your graph. Double check the description. If you are visual, this unit's going to be pretty easy for you. If you struggle with visual, this is going to be difficult. And I'm going to give you tips as we go along for the non-visual people. Okay, let's go on to apparently the second letter B, because I don't know my alphabet. That's okay. I be not your English teacher. First thing we check is the Y by itself. No, what do we need to do with that -2? We need to move it over and isolate the Y. Take away the numbers. Which base graph are we looking at? The quadratic, the square root, the absolute value, or the cubic? The square root. Again, take away the numbers, it's whatever's left. So draw me the base graph of a square root. It is a swoopy. And again, for now, you have your cheat sheet. Eventually, you will have drawn these a dozen times, and you'll know what they look like. Step 2, we're going to identify the transformations. Now, mathematicians, although we are fussy people, we are lazy people. We don't like writing words because that takes too long. We also like leaving out brackets where really there should be brackets. So there are actually brackets under the square root. We tend to drop them because we understand if it's under the root, they're together. But for non-visual people, that might help to signify what is inside brackets as opposed to outside. So although we don't write them mathematically, there should be brackets there. So this 4 is really inside brackets because it's under the square root. So is that horizontal or is it vertical? Horizontal. And it is 4 units to the left. The 2 is outside brackets. It's outside from that square root. It's off by itself. So that is a vertical translation, 2 units up. Step 3, we're going to draw that. And what color will we draw that? Red, not pink, not purple, not this is red, because that's not red if you're just making a note that in black that it's red. We are counting 2 units to the left and 2 units up. So I'm going to start at the origin. 1, 2, 3, 4, 1, 2. 1, 1, 1, 2, 3, 4, 1, 2. 4, 2, 1, 2, 3, 4, 1, 2. 9, 3, 1, 2, 3, 4, 1, 2. Swoop. Again, sometimes it bothers people that it seems like the left-hand side is just dangling, so sometimes I like to put a big dot just to remind myself that's an end point. There's nothing to the left of that. It just kind of hangs around there. Double check. Go back to your description. Did we do what we said we were going to do? Did it go 4 to the left and 2 up? So look back. Look at the black to the red. Did it go 4 to the left and 2 up? And again, you're going to think this is silly at the beginning, but when we're doing multi-transformations, it's always good to just go back and check. Did you guys forget to tell me domain and range? Thank you. Thank you, Nick, who was paying attention. Shame on you guys. So let's go back to our cubic. Cubics are awesome because they always have arrows on the top and the bottom. So they're kind of like linear functions. So what that means is the left is always all the way to negative infinity and the right is always to positive infinity. So what is the domain going to always be? Negative infinity to infinity if you like interval notation, if you like set notation. XER. It's always going to be that for a cubic. Look down. Oh, still an arrow. Look up. Oh, still an arrow. What does that tell you about the range? It's either going to be negative infinity to infinity if you like interval notation. If you like set notation, close. But this is an X. This is YER. Again, don't mix and match. No, because there's an arrow down here. Arrow, arrow. Now I'm going to guess you're backwards from the other class. How many people like the interval notation with the infinities? How many people like the XER, which is set notation? Oh, actually, you're split about 50-50. They were way more towards set notation. Set notation is this one, XER. Okay, this guy here. Left and then right first. So left, that's why sometimes I like to put the big dot, because it reminds me it's a clear end point. So what's the smallest possible x value? -4. The arrow on the right means it goes on forever and ever and ever and ever, so the highest x value is. And what do we do for brackets when there's a number? Square bracket for the number, round bracket for infinity. If you like the other notation, how do we say all the numbers that are between -4 and infinity? All the numbers larger than -4. X is greater than or equal to -4. There's the corresponding set notation. Okay, now we're looking at y, so we're going down then up. And again, the dot sometimes is helpful. I come here, no graph, no graph. Ooh, where's my lowest y value? At 2. The arrow goes up and up and up forever, so my highest y value. What kind of bracket with the 2? What kind of bracket with infinity? If we want to do the corresponding set notation, how do I say all the numbers that are bigger than 2? Don't mix and match. Pick whichever one you like better. Here's a great workbook question that'll come up, working backwards. I'm going to give you a function. I didn't draw it on there for you because I wanted to draw us together, but it would be given. And then they're going to ask you to go backwards. So I'm going to give you, like Jeopardy, the answer. You're going to give me the question. So together we're going to draw the end graph, so we're doing it in red. Again, this would normally be given. I just wanted you to draw it with me. Because it's like Jeopardy. They're giving you the last one. They want you to go backwards. So I want you to put a point at, let's go -4, 4. And -2, 2. And the origin. And 2, 2. Ah, that's funny, 2, 2. And 4, 2. And 6, 2. And I'm going to play connect the dots. So I'm literally joining them in order. Like in kindergarten, except it's not going to make a cow or a rainbow. And I put an arrow on the right. Why? Because I can. So we wouldn't normally have to draw this. Usually it's given in the question. So the question has given you the answer, the final graph, and said work backwards. What did you start from? And they won't give you one of the standard base graphs. They're going to give you something really funky like this one. So they want to know is, can you apply this to any kind of graph in the world, even something funky like this? Okay, so let's talk about these transformations. Let's talk about the -2. Inside brackets or outside brackets? So that is a horizontal translation, and it would have been 2 units to the right. And the 3, inside brackets or outside brackets? Outside, so that is a vertical translation. 3 units up. Well, that's what we would have done to get this graph. So how do we go backwards? We do the opposite. So we still want to do a horizontal translation, but to go backwards, we want to do 2 units to the left. And we still want to do a vertical translation, but we want to go 3 units down. Okay, so it's just a backwards question. They've given you the final. They want you to go back. The reason they've just called this f of x is because it's not a particular base graph. It's not like it's x squared or x cubed. It's just this funky looking graph over here. Okay, so pick it up and count. 2 to the left, 3 down. So take a look at mine. I have done a really classic final exam mistake, and I have lost myself a half mark, and now I'm sad. You have to match the graph. So if there's a point on the left, I put a point on the left. If there's an arrow on the right, I have to put an arrow on the right. Okay, so just match the graph. If there's an arrow, you put an arrow. If there's no arrow, you don't put an arrow. That's a half mark off.